Hi. Today we're going to talk about making the robot move autonomously dead in, in this simulator using a strategy called dead reckoning. Dead reckoning, simply put, is making the robot go at a certain speed for a certain amount of time. That's it. Go straight in a straight line for 3 seconds, then stop. That's pretty much it. So the way we're going to do this is first thing I'm going to go to my actuators. Those are our motors. And I'm going to set my left motor to reverse. Now, the reason is because if I have both motors and they're spinning like this the same way, when I turn them, they're actually going opposite because of how they're positioned on the robot. So I'm just going to put this at the beginning of my code, and now I can ignore that problem. And it'll automatically just flip the other one so it seems like they're both going the same way because I put this bit of code in. So now I'm going to go and get dual. And in the sim, the two motors are called motor left and motor right. On your robot, they might be called something different. These are good names for motors. So what I'm going to do is I'm simply going to set each one to one. One is full power, all right? So if I run it, bam, looks like I'm done, but there's a problem. I'm not done. I have to keep, it says badge acquired, wrong O, because I'm going to go back to keep working. Come on. Because it's actually still ramming into the end. It didn't stop right on there, and I want it to. So the other thing I can do is if I were to make this 0.5, it would just go at half speed. 1 is full speed, 0.5 is half speed. Take a look. It's kind of going slower. But I'm still having the same problem. It's still like ramming into the wall here. So I'm now going to make it stop. And just for the point of this, I'm going to make it back to full speed. I can also do it -1, that'd be full speed going backwards. So what I'm going to do now is I'm going to actually make it stop by grabbing the motors and having them stop. Now let's see what happens. It'll go at full speed and then 0 is stop. All right, well, nothing happened. And the reason why is because the computer is ridiculously fast. It just ripped right through here so fast that we didn't even get, it probably moved a teeny tiny amount, but we didn't know because the computer is so fast. It just plows through this program. So what we actually need it to do, I'm going to go to linear op mode, and we're going to tell the program to sleep for a moment. And that means it'll go here and it'll pause and let that motor go, and then it'll go down here. And right now, 1,000 milliseconds is 1 second. I think that's probably too much. I'm going to try 300 seconds, 300 milliseconds. And see if that's enough to get our robot to where it goes. So it went for, that's 1/3 of a second essentially. It went full speed for 300 milliseconds and then it stopped. Not far enough. Looks like it's about halfway. So I'm going to try 600. I'm going to try it again. Ooh, pretty good, but I want to be completely on there. Let's make it 800. This is 800 milliseconds. So this is not the speed. Here's your speed. But this is how long you want it to go because the program is stopping and letting it go for it's sleeping and then it's going forward. If you didn't do that, it would just rip through so fast. So I'm not, it keeps saying I'm done. You're not done until it looks right. There we go. Until you've stopped on the thing. Here we go. Boom, pretty good. And I might say, well, maybe I'll make this 750 because it went a little far, but that's okay. Good enough for me. And that's it. This is called dead reckoning. And this is the pattern you'll see a lot. You're always going to reverse the one motor because it's on the other side. If you have 4 motors, you're probably going to reverse 2 motors. Then you call this to, you call the simulator, or you set it to a power. You pause the program so that it can actually go for that amount of time. And then you set it to 0. And every time in dead reckoning you want something to happen, you follow this pattern. Set the power, call the simulator to sleep, and then set the power to